Hi, everybody. I guess you can call me the hype man. So, I guess let's hype up some AI. I wanted to comment about the term AI. If I remember correctly, years ago when I took an AI class in college, there was a book by Russell and Norvig, and I'm paraphrasing here, so I could be wrong. Feel free to raise your hand if you remember this more accurately than I do. But they in this book, they basically said the term artificial intelligence, the term AI, is always what we haven't solved right now with computers, right? So once we solve it, it's no longer AI. The AI is the next big thing, right? So that's one definition for AI. Personally, I think you shouldn't necessarily worry too much about these things, but that's my opinion. So today I'm going to be giving a talk. The title of the talk is From Chaos to Catalog, the AI-driven path to reporting harmony. If you'd like to get a copy of my slides, get a copy of this, get a picture of this QR code, it's up on my GitHub. I'll have another copy of this QR code at the end of the talk in case you missed it. So I'm Michael Becker. I'm the founder of DataPhilly. There's a lot more people involved these days, so that's really awesome. Thanks to all of our volunteers. And I'm a senior data scientist at Penn Medicine. So I'm going to talk to you about some work that we're doing with large language models at Penn Medicine. So let me set the stage for you here. You have the BI jungle, thousands of dashboards across Tableau, SSRS, and Epic, if you've ever heard of that. And it's a complete sprawl of untamed data wilderness. There's dashboards created by many. Ownership and relevance of the dashboards is often unclear. So our quest is to identify the vital dashboards for cataloging and transitioning our dashboards to Power BI, and so that we can abandon obsolete dashboards in the process. And this is a cross-domain collaboration, so there's a lot of coordination needed across the various domains inside the health system for a comprehensive dashboard migration. So here's our proposed solution, an AI-driven solution. So use AI as a guide. So the plan is to leverage large language models to catalog and structure the BI landscape. And so the goal is to use that to create a harmonious catalog. So transitioning from chaos to a well-organized, accessible dashboard system. And we're seeking standardization. So we don't just want to transition the dashboards. We also want to create common data assets in the process, so we can eliminate some duplication and foster efficiency. We also, we're trying to create a unified reporting ecosystem. So, we're using AI to streamline the processes and of consolidating the reports and, for enhanced decision making. So the problem space. So, I'm sure you're all familiar with the iceberg visual. So, at the top, very high level, you can think about this problem as just trying to consolidate our dashboarding tools. But under the surface, there's all these other things, right? Like improving processes and standardizing metrics, reducing reporting inventory, enhancing data quality, creating ontologies. Those are just like a few examples. So, our goal is to create a more efficient, streamlined, and user-friendly reporting ecosystem. And at Penn, so sort of the catalyst for all of this is at Penn, we have 2 instances of Tableau, we have 1 instance of Power BI, we have 2 instances of SSRS, and we have 2 instances of Epic, which is the electronic medical record system, which also contains some reporting functionality. So who is this for? So our stakeholders, our primary stakeholders, they're report end users, business intelligence leaders, report developers, and also subject matter experts and domain leaders. And so, what sort of benefits are we trying to provide to them with this effort? We're trying to do things like improve the discoverability of reports. It's, the current system, it's very hard for people who aren't familiar with what particular report they're looking for to find the report, a report that is useful for their use cases. We want to enhance the data request process. So, if someone comes to our team, the Penn DNA team, and asks for a new report, this can assist in that process, providing better insights, of course, and helping us with this migration to Power BI, making it more efficient, and just increased domain awareness as well, I think, is another major aspect. So again, this is kind of a visualization of what we were discussing earlier. We have 2 instances of everything, and we have also 2 entities at Penn that are running these 2 separate instances. So we have the main entity at Penn, which is headquartered just down the street from here, and then we also have Lancaster General Hospital. So, the goal is to consolidate all of this into, our worldview of reporting. And so as part of this process, we're utilizing Databricks. So Databricks, for those of you who aren't familiar, it's in our case, at least, it's a cloud hosted platform. It's built on Apache Spark, which is, a distributed computing platform, and something called Delta Lake. So, it provides distributed computing. It allows you to use multiple programming languages like SQL, Python, R, and Spark. It supports data streaming. It provides functionality around security and BI tool integration. So the benefits of using Databricks is, in our case, better collaboration, easier collaboration, data democratization, scalability, rapid upgrades, and it has integrated ML and AI functionality as well. So for our project, we're using this concept called bronze, silver, and gold architecture. It's like a data architecture. It's very common sort of data architecture pattern that's used in these kinds of cloud environments. So right here, what I'm showing you is what we call the bronze layer. So this is like the initial landing zone for raw and unprocessed data. So data in this layer may come from various sources and can be structured, semi-structured, or unstructured. And the focus is on capturing data in its original form without any transformation. So this is like the beginning of the ETL process. So we're extracting our data from Tableau, and Tableau was the first system that we tackled here. So we extract the data from Tableau's Postgres database, and we also use their API to download the definitions of the dashboards themselves, which are stored in XML. And we ingested all of that into Databricks. So that's the first step of the process. The second step of the process is the silver layer. All right. So the silver layer is in this layer, the data from the bronze layer undergoes initial processing, cleaning, and transformation. The goal is to refine the data and create more structured and consumable data sets for further analysis. So data in the silver layer is often used for exploratory analysis and reporting purposes. So this builds upon the bronze layer. It's the first step after the extract in your sort of ETL pipeline. So so in our bronze layer, we've parsed we have some Python code here you can see for parsing those XML files that have all the information about the Tableau reports. And we're building data sets for mapping, and it refines. So it refines and transforms the raw data into a more usable and structured format. And then we have our gold layer. So the gold layer contains the most refined, trusted, and valuable data sets. So this is like your curated data, right? Data in this layer has undergone rigorous processing, validation, and enrichment, is often used for critical business reporting, advanced analytics, and machine learning applications. This includes things like structured data, the extracted XML, and large language model enhanced content. So like things that we do with like the data in the XML and combining it with the large language model, that goes into sort of our goal there in this use case. All right, so next, let's just talk briefly about what large language models are for those of you who might not know. It sounds like most of you probably know, but so they're advanced AI systems. There's that AI term again. That process and generate human language. They utilize vast text data to learn patterns and nuances. They're powered by a type of technology, usually powered by a type of technology called transformers, which are a type of deep learning architecture, and something called self-attention or attention. I mean, there's many types of attention, but self-attention is a common type of technology used in these models for context understanding. So they're capable of text generation, summarization, and more through the next word prediction, as we were discussing earlier. So they range from millions to billions. I think Elon Musk's model actually has a couple trillion parameters for some reason. So they enable deep language comprehension. And their impact is, they propel generative AI. They enhance natural language understanding and natural language processing. And so, let's see, I think I have a pointer here. Yep. So over here in the top corner, this is a demonstration of something called word vectors. And so the concept of word vectors are essentially that it's like the precursor. You can think of this as the precursor to modern day transformer models. So word embeddings are actually used in transformer models. So the concept of a word embedding is that you can feed a ton of text data into these word embedding models, and at the end of the process, you'll have a model where the relationship between man and woman, for example, is going to be like a similar relationship to that of king and queen. And you can see you have like these things that are similar concepts are close together in this vector space that is created by these embedding models, whereas things that are unrelated are further away. So you can do some interesting things with these word embeddings. You can do math essentially with these word embeddings. And so they're sort of like a building block of these large language models, and then large language models themselves in the bottom corner here. So you can see, you can give a large language model something that is like this darker text here, and it'll predict the next word. And these are the potential words after that, for example. And so let's just talk briefly about large language models in healthcare. How could they be used? So these are all somewhat hypothetical use cases, although some more hypothetical than others. So they can be used for data analysis, so revolutionizing the processing of unstructured data, like clinical notes, for example, for insights and summarization. I think this is a pretty exciting use case, personally. Boosting efficiency, so they offer scalability for analyzing vast data volumes quickly, improving decision-making processes. And I think one thing you want to ask yourself when you're applying large language models is, what error rate is acceptable for what I'm working on? Certainly, large language models are going to get it wrong sometimes. Sometimes they're going to hallucinate, but what's the alternative, right? Do you have enough humans that you can throw at the problem? So if you have a problem with lots of data and not enough humans to work on it, maybe this is a useful solution to you, but certainly it depends on what's your acceptable error rate, right? Enhancing patient support. So, I mean, chatbots are nothing new. Large language models, as Tim said earlier, large language models have been around for quite a number of years, and they power chatbots. They've powered chatbots for quite a while. They use for natural language understanding, which is a primary feature of chatbots, and virtual assistants for better patient engagement. So hopefully, as large language models and generative AI models improve, so will our intelligent chatbots. And versatile applications. So they can be used for language translation, research assistance. There's lots of people looking into using large language models to help with research. Also, I mean, another big area that is hyped up these days is using it to like pick candidates for clinical trials, for example, and content generation in healthcare. And they provide cost-effective basis for diverse applications, avoiding the need for domain-specific models. So briefly, I just want to talk about what we chose for our, what large language model we chose for our application, for our purposes. So we chose GPT-4. Why did we choose GPT-4? Why did we choose Databricks even? And you know, what we have here is, and this is actually an old screenshot. I wish I had updated it. But there's this thing called the chatbot arena. You can go on Hugging Face and check it out. They basically run some standard. There's actually this one in particular is the ELO arena. So these are human preferences. So if you're familiar with chess, ELO is a scoring algorithm that is used for chess. So that the people with the higher, you know, the grandmasters, they have the highest score. You know, people who are new, I believe, start off with a score. I mean, you can start their scores off at anywhere, but I think adult players start off around 1,500 in chess. So this is a similar process, a similar ranking model that's being used here. Basically, there's this website. You can go there yourself. It's pretty cool. I recommend you check it out, the Chatbot Arena. And you can go there and it will give you 2 random large language models. And so and then you can enter anything you want into the chat box. You can have a conversation, and that data does, and then at the end it will ask you which output, large language model output did you prefer, and so you can vote. Your vote can be used for this ranking algorithm. And so, you know, there's a lot of options here, and this has grown probably exponentially. This list has probably grown exponentially since this screenshot was created. So why do we choose GPT-4 versus all of these other options that are out there? So HIPAA compliance. So we're running GPT-4 on Azure, Microsoft. Thank you, Microsoft. And we're able to run it in a HIPAA compliant fashion that way. It runs on our own Azure instance in Azure. And so, you know, our data can't leave our network. So this is like kind of a hard requirement, right? You know, we have API access, which makes things easier. We don't have to spin up dedicated compute to run these large language the GPT-4 large language model in Azure. So that's really handy. It handles token management. So it helps us with token management, I should say. So sort of managing cost accounting, and you know, provides a collaborative space with when we combine it with Databricks. So you know, this is Databricks is where all of our teammates hang, right? But we have limitations. There are certainly other valid approaches, but this approach, at least for now, allows us to move quickly. We can't try all the models. There's thousands of models now. We're not going to try them all. So we start with what is probably the most powerful model. I mean, I haven't checked today. I think last I checked, GPT-4 is at the top, and right below it is Llama 3. So I'm actually pretty interested in checking out this also. But GPT-4 is easier still. So I definitely recommend if you're looking for something quick and probably nearly the most performant for your application, I recommend you start with GPT-4. And it maximizes our engagement with users. It allows us to focus on like what really matters, right? Which is making progress on our project instead of all the technical aspects. And so here's, from a high level, the process that we followed for our project. So you can break things down into these 3 levels essentially. The first level again is that structured data and the raw XML. And then level 2 is we parse the XML files to pull out the useful information about the dashboards. And then level 3 is employing our large language model to try to speed up this process. So level 1, again, we have a bunch of tables in Databricks is what you're seeing here. So it gives us things like workbook, so workbook in Tableau, for those who aren't familiar, is essentially the name for a dashboard in Tableau. So, it gives us things like workbook to data connection attribution. We have user access logs, which are useful for figuring out who uses this dashboard, right? Because it's not always obvious looking at the dashboard itself. And so level 2, this is where, we're parsing the XML. This is that XML parsing code again. So this allows us to gather things like field names. So you can see what a field name looks like. This is a part of a Tableau dashboard. And you can see, this is what a field name looks like, right? So we want to extract all these juicy text fields so we can give them to our large language model. So it includes, dashboard, other things like dashboard worksheets and other metadata. It includes the actual SQL code that is run by not every dashboard has SQL code, but for those that do, it includes SQL code. And then level 3. So this is how we interact with our large language model. So here's an example. On the left, we have a prompt. I'll get into more details about what a prompt is in a moment. So our prompt here is list any metrics that are used in this workbook or by users of this workbook. You should consider both metrics that are standardized and used universally across all healthcare organizations, along with metrics that might not be standardized by a standards body. So this is an example. And then you can see here's what an example output for this particular dashboard that we're looking at would look like as an example. And so tying everything together, we have Tableau, our data coming out of Tableau. We have our level 1 and our level 2 sort of structures that we've extracted from the Tableau server. And then we feed those details into our large language model, and it outputs, our output is, these data products essentially, right? So we have terminology extraction, classification, clustering, summarization, and usage statistics. And here's another a more detailed breakdown of sort of the things that we're producing as data products from this effort. So we have again our level 1 data here, which is our user metrics, for example. We have in our level 2 data, we have information that's scraped from the XML and used for instructing the large language model. Level 3, we have 3 products that we're producing right now. So we have large language model generate summaries. We have these concepts of subdomains in our team. So these subdomains are basically different parts of the team, right? So you can imagine one subdomain, for example, is hospital operations. You have another one, which is ambulatory or outpatient operations. You have subdomain for finance and things like that. So these are the different domains. So we're trying to do classifications. So that's one of our products that we're producing. And we have this concept that we've been playing around with called tags. So these are specifically what we're trying to do is see if we can utilize these large language models to extract useful categories, basically. And so let's talk about prompt engineering real quick. So what is prompt engineering? Prompt engineering, it maps the user's needs to AI capabilities. So it turns complex desires into specific, understandable requests for the artificial intelligence. So it requires understanding the context of the request and transforming them into detailed prompts for meaningful and accurate AI responses. It's not a science. It's kind of a combination of art and science. So it requires converting user queries into structured prompts that provide the right context to the AI, and it improves the AI's efficiency and relevance of its output. So it's the intent here is to optimize the response of the generative AI to meet your real-world needs. And it employs a variety of techniques. So from simple direct requests to advanced strategies like chain of thought, few shot learning, and directional stimulus prompting. So it enhances the AI reasoning and output relevancy. So here's an example of what a large language model prompt looks like. So if you've used ChatGPT, I'm sure you know what this means, but here's an example of a prompt. This is an article followed by a summary written in informal language. And then you would input, the article, and you would provide sort of this prompt to the model saying, in summary, and then you'd leave it blank and let the model generate the rest. So that's basically a prompt, right? You'll see more examples. So let's talk about some different types of prompt engineering, right? So the simplest form of prompt engineering is called zero-shot prompt engineering. And so it's called zero-shot because you're providing absolutely zero information to the model. You're just asking it to answer a question. So who is DataPhilly? Summarize the key points in bullet point form. I love this particular kind of prompt. So when I ask Claude, who is DataPhilly, it says, I have no idea who DataPhilly is. Sorry, right? It's not hallucinating. It's just telling you it doesn't know. Look at that. We're getting better already. And so, that's not very useful. So you might try something called one-shot learning in this case, or, just maybe generalized to be into like a concept of n-shot learning, right? So this is one shot in the sense that you're giving one example, right? So I ask it the exact same question, but now I've given it the full contents of the DataPhilly Meetup page. And now it produces useful output. Based on the information provided here are the key points about DataPhilly. All this stuff seems correct to me. I don't think it's hallucinated anything. So this is a good way to ground your large language model's responses, right? Prevent hallucinations. It's not a silver bullet, but it certainly helps. And then you have, an n-shot example. So what do I mean by n-shot? So in this case, I'm providing multiple examples, right? So using these examples, complete the new item below. So this is very similar to what we saw at the beginning, right? But so I have here, I'm describing the color of various different things here, basically, right? So the sky is blue, rubies are red, Neptune is blue, so on and so forth. And I'm asking the large language model, how would you complete this? Poppy, and then, something, right? Question mark. So the large language model correctly responds with red, right? So this is an example of n-shot. Here's another interesting example. I gave it only examples with blue and red, right? But when I ask it what about a plum, it responds with purple. So you don't need to hold its hand. This is something that it's learned through its training data. An important thing you need to be mindful of when you're doing prompt engineering is that any change, even a minor change to your prompts, can significantly shift the AI's response, introducing unintended biases. So each change in the wording or context of your prompt acts as a nudge, potentially steering the AI towards different interpretations or emphasis. So identifying and mitigating these biases requires careful consideration of how prompts are constructed and adjusted. And this highlights the importance of iterative testing and refinement to discern and correct the biases of your AI responses. So I want to give you I think a really good example of this bias in prompt engineering. So this was posted on Twitter. You can find the link. If you can't read that link, you can find it on my GitHub. If you can download the slides and find it yourself. So this is a quote from one of the Claude developers, I believe. They said, we found that, so for those of you who are unfamiliar, Claude is a competitor to ChatGPT. We found Claude was a bit more likely to refuse tasks that involved right-wing views than tasks that involve left-wing views. So they have this particular part of the prompt that they've added here. I'll read it off to you because I think it's a little bit small here. And they said that they added that this part of the prompt encourages Claude to be less partisan in its refusals. So the part of the prompt here reads, if it is asked to assist with tasks involving the expression of views held by a significant number of people, Claude provides assistance with the task, even if it personally disagrees with the views being expressed, but follows this with a discussion of broader perspectives, right? So they've introduced this part of the prompt to try to fix some biases that they notice in the model, right? But then, this is again a quote from the author, the nonpartisan part of the prompt, the previous part that we were just looking at, can cause the model to become a bit more both sides on issues. And this part of the prompt, this next part of the prompt, tries to correct for that without discouraging Claude from discussing such issues. So this next part says, if asked about controversial topics, Claude tries to provide careful thoughts and objective information without downplaying its harmful content or implying that there are reasonable perspectives on both sides. And then, so what I want to, what I'm trying to highlight here is, they identified a bias, they introduced some changes to their prompt, it introduced another bias, they had to make adjustments, right? So every change to your prompt biases the large language model's output, right? It's an X word prediction model, right? So everything you put in that prompt is going to bias that output. While iterating on your prompts, it's important to test with a variety of examples. So, one shot or n shot, to better understand the impacts of your prompt engineering efforts. So I wanted to briefly touch on some more advanced prompt engineering techniques. So there's this type of prompt engineering technique called chain of thought. The goal of chain of thought prompting is to improve the reasoning ability by inducing the model to answer multi-step problems with intermediate steps. And it allows the model to handle tasks requiring logical thinking and multiple steps. And it can be, in my experience at least, it can be useful for identifying potential ambiguities in your prompts. So there's here's an example of a chain of thought prompt. This is not the only way to approach this. And there's a section in here, if I can find it, that basically says, discuss what might be ambiguous in the prompt, essentially. So I find this, it's useful for many purposes, but I especially find it useful when I'm prompt engineering because it can tell me this part of your prompt was maybe a little bit ambiguous. You don't want the model to be confused, so you can provide clarification. And then this is another technique that I've utilized. It's called self-refine. It's also been called auto prompt engineering. So the idea is that you create a loop for the artificial intelligence, for the large language model, right? So you solve, critique, improve, right? And so the idea is that this will increase accuracy. So it allows it to refine its own prompt and its answers over several iterations, right? So the self-refining process, it's up to you when it stops, right? So you could set some sort of token limit. So maybe I have a cost budget, right? I only want to spend this much money on the auto prompt engineering. Or maybe you have a time budget, or maybe you have just some other approach for deciding, okay, this is good enough. It doesn't seem to be improving anymore. Let's stop here, right? So it uses its own output for improvement, and it's ideal for complex tasks. And so, as I said, you can use this for auto prompt engineering, to refine the prompts through feedback loops. And so here's an actual example. This is a completely different project that I worked on, but this is an actual example. Evaluate the following responses to patient requests based on how closely they align with the gold set responses in terms of tone, vocabulary, directness, sentence length, and overall response length. We try to score between 0 and 10, 0 being least similar, 10 being most similar for each large language model output. And so we have here large language model 1 output, large language model 2 output. So each of these were generated with different prompts, right? And then we have our gold setting. So in this case, the gold set is an actual response by a clinician to a patient message. And so the question is, did this prompt look better or did this prompt look better? That's basically what we're asking the AI to decide, right? And so we actually were able to utilize this to improve the tone of the responses of another product for generating auto responses, like your automatic spell checker, like Tim was alluding to patient requests. And so that's prompt engineering. Let's just talk more about this particular project that we're working on, going back to our reporting catalog work, right? So here's an excerpt of our prompt for summarizing SQL queries. This is sort of the first step of our process. So it says, you are an expert in reviewing SQL code and deciphering its intended use, et cetera, et cetera. Generate a short summary of the apparent purpose of the report in a single paragraph. Your summary should be short enough to fit in a single paragraph, but detailed enough that I could hand it to an experienced data analyst. And so here's an example output from our data set. So we can see it says, the workbook appears to be a comprehensive tool for monitoring and analyzing the performance of various departments within Penn Medicine, with a particular focus on, and the workbook includes worksheets and dashboards that provide different views of the data, including performance over time, etc. So this is one of our intermediate data products. And then we also have another prompt that we're using to try to do that domain assignment or classification, right? So we're saying list up to 5 subdomains. We've given them the definitions of our domains with lots and lots of details about like what goes into this domain, what goes into another domain. And you can see this is an example of what the response might look like, right? So it's saying for this particular report, it falls into the quality and safety domain, and it gives, we've asked it to give justification and evidence of that, right? And it also says it might fit into these other domains. So this is another example. And then we've done something similar with this concept of tagging. So this is a more open-ended. As opposed to like providing the categories up front, we're basically saying, what sort of metrics that are industry standard or even not necessarily industry standard do you see in this report? And then here's one view of the output of this process. So we've run this on around 2,000 dashboards so far, and we can see, we've created a dashboard for our dashboard. So, most of the dashboards fall into the hospital operations bucket according to ChatGPT. And, we asked it to provide confidence levels as well. I think the jury's still out if that's actually useful or not, at least the way that we've implemented it. So yeah, this is kind of a high level view of the output of our work. And then finally, we did some actual validation of our results. So this is how we validate our results. We have some domain leaders and clinical subject matter experts. They performed a quality assurance review of our results. And so they evaluated the large language generated summaries, the domain assignments, and the tags. And it took about 20 to 30 minutes per Tableau dashboard. We did this for about, I think, 20 dashboards was the sample that we used. And so they scored the subdomain assignment and the tag validity and usefulness between 0 or as either 0 or 1. And they provided a subjective accuracy score between 0 and 1 for the large language model descriptions and tags. So this is the feedback we got as part of that validation process. So what worked well? So the average subjective accuracy score for the summaries was 0.87, basically a B+. And some of the feedback we got from our reviewers were, overall, I was impressed. It's doing a fair job. It drew out insights that connected the dots. The summary was pretty well written. Its assumption on what is done with the data based on my experience in primary care is exactly right. And so some areas of improvement that we identified as part of this validation effort. Some summaries included information not visualized in Tableau. So it's unfortunately not uncommon, we've discovered, that data analysts will copy and paste SQL code. So they'll say, okay, I have another dashboard that does almost what I'm trying to do here. They'll just copy the SQL code. So the SQL code has things in it that aren't visualized at all in the dashboard, right? So that was one of the sort of downsides of our approach here. And the summaries contain technical details more helpful to developers than layman end users. So we actually produce multiple types of summaries, but we have what we call an enhanced summary, and the intended user of that is actually a data analyst or report writer, rather than, for example, the domain manager. So we discovered we need to create different types of summaries for different types of users, right? And so on the subdomain assignment and tagging side, they found this was, I would say, a little less successful than the summaries themselves. So the subdomain assignments, the feedback was we found it very difficult to list any Tableau as not connecting to any subdomain because there's just so much overlap between these subdomains, which is a real problem. It's not just a problem for the AI, it's a problem for the people who have to work in these, the domain managers themselves, right? So, a new project comes in, the domain managers have to have a meeting to decide who's actually going to work on this thing. So like the people who are working on this can't easily decide, what the subdomain assignment should be. Probably the AI isn't going to be able to figure it out any better than they can. It might be able to assist, but it's certainly not going to solve the problem. We're not talking about, level 5 self-driving cars here. The tag validity and usefulness. So the current process for creating tags, it's too simple and needs refinement. So, the challenges are that there's redundancy in the tags. So there's a lot of, because of the simple approach that we took in this first pass, you can have lots of different tags that essentially mean the same thing, synonyms for each other, right? And they're also missing tags as well. And some of the tags are just, not that interesting. Like patient demographics was a tag that GPT loves to produce. Patient demographics is a completely useless piece of information to anyone. So, almost every dashboard has patient demographics in one way or another. So the data science team feels that RAG stands for retrieval augmented generation approach. So this is another advanced, you can think of it as a type of end-shot approach, right? So the idea for RAG is that you search through your data set using semantic search. So you can utilize large language models for that as well, to identify the best examples to provide in your prompt as your end shot examples, essentially. So we're thinking a RAG approach, basically a search approach. I think someone was just mentioning something similar to this, will provide more useful end product than just simple tagging would. So this would essentially, you can envision this as like providing a search interface where anyone can type anything they want. Instead of predetermining the tags, they can determine themselves what they actually are interested in. Utilizing the RAG approach would help us with that. So our key takeaways from this project. So we socialize large language models. This is like the first major project using large language models at Penn. So we've democratized the process of adopting this new technology in our daily work. We've overcome some technical hurdles. I mean, there was a lot that went into this process before we could even get to this point, right? So spinning up the GPT-4 on Azure, it's, I think, a lot easier now than it used to be. If you correct me if I'm wrong, Jason, but Jason, my boss, Jason over here, is the one who's been dealing with most of this over the past year. So I think it's easier than it used to be, but back when we started working on this project a year ago, it was certainly not the easiest thing to set up. And, integrating it into Databricks was also, at least back then, a bit of effort. I think it's probably getting easier every day. So, there were a lot of technical hurdles. We've gotten some positive user feedback. Personally, I think that the user feedback may be too positive. That's just my opinion. Maybe I'm too pessimistic. I don't know. And so it at least confirms that we're heading in the right direction with this kind of use of large language models. It's redefining work with LLMs. So, our achievements underline the pivotal role of large language models in rethinking our work processes. Where else can we use large language models to enhance our day-to-day work? So, yeah, and that's it. Any questions? Thank you.
My question is around Databricks. Thank you very much for sharing about them. Their data intelligence platform is known for pioneering in breaking the silence between historically siloed BI reporting and data science, forward-looking predictive analytics. Curious if you could share of any use cases that you might put already on your roadmap, and how would you utilize their functionality, forward-looking functionality?
Yeah, so I think, our focus is mainly on large language models, obviously. As a data scientist, that's what's most interesting to me. They have a piece of functionality called the MLflow gateway, which is, I think, not technically in a stable release yet, but you can get a preview of it. So the MLflow gateway basically allows you to put an API endpoint in front of any machine learning model that you can then host on the Databricks platform. It can also, we're also utilizing it to connect to the Azure OpenAI endpoint. So the benefit of this and of having it in Databricks is that Databricks handles all the sort of user authentication kind of things, right? So you don't have to, if you were using, if you wanted to go out today and use the OpenAI API, like the public available OpenAI API, you would have to provide, like a key of some kind, right? So you would, and that's how they basically charge your credit card, right? They keep track of who's racking up all the bills. Databricks abstracts that all the way for us, right? So we don't need to hand out keys, individual keys to individual users. We're able to track the usage of these like ML models inside Databricks, just using that built-in Databricks functionality. So that's one of the primary benefits, at least for these applications, utilizing large language models, I would say. I'm not an expert on Databricks, so I can't really speak to every other feature in Databricks, but that is something that at least I can personally appreciate. It's gets rid of some of the barriers to getting started with large language models. So you can have your IT side of your organization set things up so that and it just like speeds up the process for everyone else, if that makes any sense.
Yeah. When you were going through the Claude prompt engineering and its biases and how to nudge it in certain directions, I was thinking, I occasionally write methods with like 3 parameters, and I change one thing, and it has unintended side effects. And these are talking about billions of parameters. I'm assuming that when you are on Azure, you're locked into a certain version of GPT or Claude.
You can choose, but yeah,
you get locked into a version. But how do you build like a testing harness around it? So when you do have to upgrade, you can find, what tendencies are broken, what's changed, what are those parameters changed that cause.
I'll let you know when I solve that problem.
Okay.
I don't know. I mean, your suspicion, I think, is warranted, certainly. Yeah. I mean, that's a whole other.
I mean, I've got a pretty good sense within, what I do, which is, pretty low level compared to this, of how to build a test suite around it. So when I upgrade, and I'm just trying to come up with a similar metaphor for as we upgrade what language models we're using. How much test coverage? What is test coverage in this?
Yeah. So
say a little something about this because I guess a sort of tangential question, but I feel like it's related recently. Is that this is one of the big things that's lacking is that none of the models that I've used or none of the products that I've used to date so far have any real ChatGPT on the web, right, has some history, right? But like a lot of things don't have any prompt history. So you can't really look at like, what was my prompt? What was my output? And then to your point, perform a test in the future on a different version and see if the same prompt generates the same or different output.
So that's
the basis of, that's the fundamentals of testing.
I haven't, needed to tackle this myself. I obviously will have to tackle it. But, you can follow the same kinds of approaches that you typically follow with AI, right? You create a test set, you label it, right? And so you have, you call it your gold set or something like that, right? So you can have you can create test harnesses, you can do CI/CD, right? And so you can say, I have a new version of my model, run my gold set against this model. And, there's depending on the data set, there's different types of metrics that you can use, standard AI metrics that you can use to measure the performance. And so you might not get the exact same response, but you can use these metrics to measure is it performing at least on par with what it was performing before? And that will maybe give you some signal that maybe you need to like revisit your prompt engineering or something like that. It might also tell you there's a regression with your new model and you need to like look into that. But I think that's sort of like the best approach. Nothing's going to replace human validation. I mean, this has been true of AI before generative AI. Generative AI is no different, right? You know, we've deployed lots of artificial intelligence models to healthcare over the years. You know, you have models for predicting sepsis, you have models for predicting palliative care needs, for example. And we've always been very vocal on my team about how, you know, if you need to rebuild the model, you got to redo the clinical validation, meaning like actual clinicians validating the output. So, you know, you can't skip these things, right? It's just like the standard work that we always have to do with artificial intelligence. So I think that those are, you know, the standard approaches these days. Maybe we'll get something better in the future, but that's what I would recommend.
I guess I'm trying to think through your feelings. So you said you had like 2,000 dashboards, and then you talked about prompt engineering. Was one person typing a prompt for each?
No, not for every single case. No.
Okay.
So it's the goal. What we do is we do the prompt engineering, and we usually throw, like I suggested earlier, you choose a few random examples, a few random dashboards, and while you're doing your prompt engineering, to see how it's impacting your results, right? And so as every step of your prompt engineering, you should be testing it with some examples and like observing the output. And then once you're confident that it's performing well enough for most cases, then you can run it for the entire data set. All right. Doesn't look like there's any other questions. Oh, one more? Yeah.
So prompt engineering. So is prompt engineering like a byproduct of this, having certain limitations, or is it just something that use it have like come up with to get more out of it?
So prompt engineering is just like a general term for writing these prompts for the large language model. So prompt is just like literally the input to the large language model. It's what you're asking the large language model to do, right? So that's where the term prompt engineering came from. And the idea is, I mean, the ultimate goal is no more programming, right? Tim? And now you only need to do prompt engineering. Of course, we're certainly not there yet, but the idea being, you know, rather than people having to learn how to program, now they can learn how to prompt.
You can just get an AI to be a better prompt engineer to.
That's my goal. That's my goal. Sure. Yeah, go ahead.
So can you elaborate on your process to prompt engineering and how you test for the ability for the model to respond to the prompts?
So yeah, as I said, like, you know, I usually follow an iterative process. I think someone here was mentioning earlier, like, you know, how can you figure out what your old prompt was, right? So you gotta follow good software engineering practices like version control, right? So you version control your prompts just like you version control your code. So each iteration of the prompt engineering process, and feeding several examples into it, along with the current version of the prompt that I'm working with, right? As I said, oftentimes I'll utilize some concepts from chain of thought like this. I looking for alternative interpretations of the prompt to try to get a sense for what could the large language model be confused with about the prompt that I'm giving it. So, you know, it's kind of this iterative process where at each step of the process, I'm looking at the results with several examples that I give it as input. And I'm also, you know, trying to identify cases where it looks like it's confused or just producing bad output, and then making adjustments to the prompt to try to address those issues. And it's, you know, as I said, it's not a science, right? It's kind of a mix of art and science, right? So you've got to be creative, right? You see the large language model messing something up, you make some changes to your prompt to try to address it. You won't always be successful necessarily, but that's the basic process. Yeah, go ahead.
Yeah, so please correct me if I'm wrong. My impression of LLMs are they are somewhat stochastic in nature.
Yep.
So it different from how you program or how you if you do like I++, they in programming, they will add one to the variable I every time, like 100% of the time.
It's much more non-deterministic, yes.
Right, exactly. So if, I mean, like that is what I had in mind. So with that, then do you do like testing? So do you feed 100 times of the same prompt and see if the different the results is the same or similar every?
Yeah, that's another good approach. Absolutely. I mean, I wouldn't combining that, of course, with different types of examples as well. Obviously, I think I get more utility out of sort of like providing diverse inputs as opposed to like repeating the same input. I think there is some value in like repeating the same input and seeing if it's producing different outputs. Most of these models do have a variable called an input variable that you can specify called temperature. So temperature is directly gives you more direct control over that stochasticity. Tim was saying earlier how like he thinks that ChatGPT has that temperature set too high, that it increases the randomness, the stochasticity, or sometimes people talk about this temperature parameter as like impacting creativity, you know. So certainly setting your temperature to 0, which is what I usually do, helps some of that stochasticity. Doesn't solve it completely, although with some models you can also use a fixed random seed as well. So there's like another variable or parameter to the model is this random seed, right? So if you fix the random seed and you set the temperature to 0, you should get deterministic results from these models.
Thank you.
So how do you get around some of the red tape for using ChatGPT with your project, given that, you know, it's closed source and there's some controversy surrounding some data collection practices?
I mean, this project, I was lucky, this project was proposed by the executive leadership, so I didn't have to deal with red tape. I mean, don't get me wrong, there's still red tape. Talk to Jason afterwards, he can tell you all about the red tape.
Well, I can talk to you.
All right, well, one more. Go ahead.
Sorry.
Yeah,
Thanks for your talk. Just question on temperature. So as you're referring to it, you make it sound like it's a dial, like quite literally, how does it look as you're changing the temperature of something?
Sure. So, you know, if you increase the temperature parameter and you do exactly what he was proposing, you know, like you give the same input 100 times, you're going to get, as the temperature dial goes up, the output is going to get more different, if that makes any sense, right? So if you do like a comparison of all your outputs, so you could do something like, there's like a simple measure, for example, called Levenshtein distance, right? It's like the distance between two pieces of text, right? So you would imagine that as your temperature increases, if you're giving it the exact same input, that Levenshtein distance of your outputs is going to increase. So that's kind of, I don't know if that answers your question.
I was thinking a little bit more towards, like, is it literally a line of code where you are saying this is the temperature? Is it like I don't know, like something more embedded in the GPT that you're using?
Gotcha.
What does it look like?
Yeah, so the API itself, like so this is like a REST API, if you're familiar with the concept. The OpenAI API itself has a set of parameters that you can set. You can use the defaults. I don't know what the temperature defaults to. Maybe it's something high, say. But it's just in your code, when you're making your call to OpenAI, you can say temperature equals and then whatever you want to set it to, basically.
Okay, thank you.
Yep. Sorry.
No, I was just gonna say. The model will output probability of words. There's a high probability, so if your temperature is kind of low, it's always gonna pick, so that's why there's less creativity, whereas if you have a temperature higher, it might pick something else even though it's not. Okay, I think.
Yes, it's something along those lines. Okay.
Are there any tools or platforms similar to, what WordPress does for people in, creating blogs and websites that allow people to create LLMs from the ground up?
I mean, some of the more popular platforms that I'm aware of are Hugging Face. So Hugging Face is I guess it's an open source company. And so they produce a bunch of open source tools and a platform that allow you to do this. I think people also often use things like Google Colab, if you've ever heard of Google Colab.
There's a neat little tool Amazon has put out to get people to use their Bedrock LLM. And basically it's just meant literally for like students in classrooms to play around and create little games. And it says like, if you create a prompt, you can create an LLM prompt for it to do something for you. So you can make it play like a little role-playing game. You could say like,
It's like a learning environment to like teach you how to use the
Yeah.
tools.
yeah, it's actually pretty cool. I can put it in the Data Science Philly Slack. But I played around with it for like half an hour and you can kind of create these little games. They're pretty neat if you want to try and get familiar with it.
It's cool.
If you have a gaming rig at home, chat with RTX, it's pretty fun.
Chat with RTX.
Yeah, so if you have an NVIDIA RTX card or greater, so 4000 series or greater, which now that the 5000 series has been advanced are finally affordable. It now comes, you can install chat with RTX and just chat with your video card at home at zero additional cost
Wow.
and do your own regs.
Yeah, there's also there's a project called Local AI. What was the one that you were using?
The LLM studio?
Yeah, large LM Studio, so like language model studio. So that's something, if you have, it looks like you have a MacBook, that's something that you should be able to run on any modern MacBook, and then you can run, it gives you like a simple interface similar to ChatGPT, is that right? And it allows you to run some of the open source models on your own laptop. One nice thing about Macs, one great thing about Macs is that they have their RAM is shared by both the CPU and the GPU. So if you get a MacBook with a lot of memory, you can take advantage, because all these models run on GPUs, right? So for the most part, you can run a lot of them on CPUs. You're just going to have a bad day if you do, for the most part. And so on the MacBook, you get a MacBook of 128 gigabytes of memory. That's more memory than you can get in a couple, 4080 cards or something like that, right? And so the more memory you have, the bigger the model you can run on your hardware. So since you have a MacBook, you're kind of can take advantage of that. Does anyone else have any other recommendations? I'm curious.
One question,
Okay,
your
go ahead.
giant pool of dashboards, do you have any a priori idea of the usefulness or the actual being used of those?
I mean, it depends. So, as I said, the 2000 dashboards that we fed through the system so far are only Tableau. We have like tens of thousands of dashboards in these other systems. Tableau does give us usage statistics. So that's really helpful. And we've already been able to get rid of some low hanging fruit that way, right? Don't even bother with the ones that aren't being used, right? So there's certainly lots of heuristics that we can apply that don't require large language models at all to help with this process. The large language models are really for, those not the things that we can easily deal with without using large language models.
60,000.
So we were supposed to be out
60,000. Oh,
by
sorry.
8 o'clock.
Yeah.
So I hate to shut the party down,
Sure.
but just so they can get things cleaned up.
I'll be out in the hallway if you have any more
You can hang in
questions.
the hallway. If anybody also wants to go out, people are, plenty of places on campus. And relays are going on, so there might be some fun things to see around campus. Absolutely. 4070 Ti, that's perfectly good. That's what I'm thinking. I mean, it would have been.
I've always really been interested in
Kevin Werbeck, W-E-R-B-A-C-H.
I mean, it was a decision made by management, essentially, you have all these different, analytic systems, I chose Power BI, I don't know the exact reasons, honestly, I chose Power BI. It's just more along the lines of, why are we paying for 8 different systems? I just felt, they chose something, it wasn't really up to us.
We're building an app.
Yeah, I think one of the, certainly one of the motivating.
Mobile apps.
Have like a lot of existing.
He comes to our events team.
I'm saying probably more.
Well, it wasn't big.
But then we on that day, like monthly meetups. So.
I know one of the organizers.
And sometimes like depends on this.
Yeah, they're.
I'm actually.
In terms of like data science. There's a data meetup that's set up, but those guys are basically.
Yeah, like. CTAs, like. Yeah. I know it's not quite what you guys. Yeah.
Yeah. Which. They have a. I don't know the details. I was gonna make.
I told him. Actually, I showed him what the customers I have. So we have an ad at Friday.
Enjoyed it. Gave me things to think about.
And they'll put it on their website. Like, you go to- They have their own website. They don't use us for that. If you go to the Gearbox website, as you see.
Oh, thanks for coming out.
I actually just joined the Slack, so.
Yeah.
Probably not.
Yeah, we can. End session. Great.
This is.
Everything's off. I'll just need 1 minute to get all cleared up.
If you're interested